Good morning, all. Welcome back to the series of the video lectures on the subject power quality. We shall discuss today to the our new topic. There is unit number 3, transient overvoltage and flicker. So just go through the contents of the unit number 3 for a while. So what are the contents? The sources of the transient overvoltages, impulsive and oscillatory transients, these are the types of the transients, magnification of capacitor switching transients, pre-insertion reactors to control the capacitor switching transients, ferroresonance, and the principles of the overvoltage protection, the devices for the overvoltage protection, then the definition for the voltage flicker, their sources, and the factors which are governing to the severity of the flicker. So let us start with the transient overvoltage. So what is a transient basically? So it is a sudden rise of a signal called as a transient, or undesirable momentary deviation of a supply voltage or the load current, also known as the surges or the spikes, are called as the transient. And these transients are classified as impulsive transient and the momentary or the oscillatory transient. So transient overvoltages are the short duration, high magnitude voltage peak with fast rising edge, commonly referred as the surges or the spikes, often described as a spike. Transient voltages can reach up to 6000 volt, 6 kilovolt on a low voltage consumer network with no more than a millisecond duration. See what is severity of the transient that will increase the voltage level up to the 6 kilovolt for the low voltage consumer network. So lightning strikes are the most common sources of the extreme transient overvoltage, where total outage of an unprotected system can occur with damage to cabling insulation through the flashover, potentially resulting in a loss of life through the fire and electrical shock. However, the electrical and electronic equipment is also continually stressed by hundreds of such transients every day during their operation. It happens every day on the power supply network through the switching operations of the inductive loads such as air conditioning units, lift, motors, and the transformers. So these events are occurring thousands of the times or the hundreds of the times. Switching transients may also occur as a result of interrupting short circuit current, such as the blowing of the fuse or tripping the MCBs. Although the switching transients are of the lower magnitude than the lightning transients, they occur more frequently, and equipment failures unexpectedly occur, often after a time delay. So the degradation of the electronic component within the equipment is accelerated due to this continuous stress of these switching transients. So I will say switching transients are more frequent than the lightning strike. So transient overvoltages, whether caused by lightning or by electrical switching, have similar effects like disruption, that is a loss of the data, tripping, degradation, reduced equipment lifespan by loss of insulation, the damages of the equipment, then downtime, the biggest cost to any business, such as the loss of the productivity and product spoilage, staff overtime, and delays to the customers and sales lost to the competitors. So these are the main effects of these transients, whether it may be impulsive or the oscillatory. That is, whether it may be due to the lightning or the switching, electrical switching. So transients. So again, let me define you transients as: it is an event that is undesirable and momentary in a nature for a short time. It is the sudden change in one steady state operating condition to the another which is undesired. So transients can be classified into the two main categories: impulsive transient and oscillatory transient. The impulsive transient, the sources are lightning, and that oscillatory, that is a momentary transients, the sources are back-to-back capacitor switching, transformer energizing, reclosing operations, and many more. So let us see the impulsive transient in our next video lecture.